This video is going to cover the second part of Chapter 10, Section 6, which is finding the lengths of the segments in the circles. So we're going to do a quick review of what we took yesterday, which was that these are now going to be segments of chords. So if I take a chord and divide it into parts, those are called segments of chords. And we learned that if the two chords intersect in the interior of the circle, then the product of the lengths of the segments of one chord is equal to the product of the lengths of the segments of the other. So if I had looked at this diagram here and just made it a little bit simpler by giving it a single letter, this is X and Y, and this is J and K, then I can say X times Y would equal J times K. Then we talked about tangent segments. So the secant and the tangents both have segments, which are going to terminate. They're going to have two endpoints. And the two parts of the secant segment are the external segment, which is here, and the entire segment, which is here. So we're going to use those in the next theorem, which says this: if two secant segments share the same endpoint outside the circle, then the product of the lengths of one segment is equal to, and its external segment equals the product of the lengths of the other secant segment and its external segment. So this is where we left off yesterday. This is whole, so this would be this whole part times external, which is the MN, would equal whole, which is this whole tangent, or secant segment, sorry, times its external, which is here. So in this diagram, LN times, which is the whole segment, times MN, which is the external part, would equal NP, the whole segment, times ON, the external part. And the last theorem in this section is 1016, which is the segments of secants and tangents. So now we've got a secant and a tangent. If a secant segment and a tangent segment share an endpoint outside the circle, then the product of the lengths of the secant segment and its external segment equals the square of the lengths of the tangent segment. So it's, again, a lot of words for this simple statement, which is that the tangent squared, which would be ML squared here, would equal the whole secant segment, which would be JL, times the external part, which would be KL. Okay, let's work some examples. So example 1, if I look at A first, we're finding the value of X here. This is the example of that first theorem, which is the two chords. And we said if two chords intersect inside a circle, then the product of the lengths would be equal. So 3 times X, or X times 3, would equal 2 times 12. And then from there, I would get 3X equals 24. Divide both sides by 3. And X equals 8. Now, if you look at B, this is a tangent and a secant segment. So remember that the tangent squared equals the whole times the external part. So the tangent squared here is your X. X squared equals the whole segment, 18 plus 6, or 24, times the external part, which is just the 6. And I get X squared equals, now I can multiply out that 24 and the 6, so 24 times 6, and I get 144. And this time it's a perfect square, so when I square root, I get a nice round number. You might find that that number is not a perfect square, so let's say it was something like the square root of 120, for example, and then we would use the factor tree to break that down until we found the product of primes. And then for each pair, one of those numbers comes to the outside. None of these have a match. So that would be 6 times 5, or 30. So again, in this case, it was a perfect square. So my answer is X equals 12. If it was not a perfect square, then we would break it down using our factor tree. Example 1 continued. Part C is two secant segments. So I want to do whole times external equals whole times external. So the whole here is 12 times the external part, which is 4, equals the whole this time, which is X plus 6, times the external part, which is 6. So on the left-hand side, I'm going to multiply the 12 and the 4, and I get 48 equals, I'm going to distribute this 6 into both here, 6x plus 36. I could have also divided both sides by 6. It's just another way to do it. Then I'm going to subtract the 36, and I get 12 equals 6x. Divide both sides by 6, and I get x equals 2. D is tangent and a secant. So tangent squared equals whole times external. So tangent's 10, 10 squared equals the whole. This time my whole is x plus 2x, which is 3x, times the external part, which is x. And I get 100 equals 3x squared. So now to isolate that x squared, I'm going to divide both sides by 3. And I get x squared equals 100 over 3. Now that doesn't go in evenly, and I'm going to end up square rooting it. So I'm actually going to leave it the way that it is for now. I'm going to square root both sides, which means I square root both the 100 and the 3. Now we know the square root of 100 is 10, but the square root of 3 is an irrational number, so it stays that way. And we cannot leave it in the denominator. So we rationalize by multiplying both the numerator and the denominator by the square root of 3. And I get 10 root 3 over 3. So x equals 10 root 3 over 3. So that's the end of the notes for 10.6. We're going to do a quick refresh on what we learned in 10.5 and 10.6 since there were so many things in there. And then you're going to get time to work on your homework assignment. So this is those angles in and on the circles. This was from 10.5. And basically, well, actually, it's from before 10.5 because it's got the central angle and the inscribed angle. But the last couple are from 10.5. So remember that these are all the 1, 2, 3, 4, 5, 6, 7. Technically, there's 7, but the last 3 are kind of the same types of angles. And then each one has a different way to find the actual measure of the angle. So when we're dealing with the central angle, okay, remember that the angle has its point on the vertex. And if that's the case, then the angle equals the arc. So in this diagram, the measure of angle 1 would equal the measure of arc AB. The second example is an inscribed angle, and that's when the vertex is on the circle itself. And here, the angle is equal to 1/2 the intercepted arc. So in this diagram, the measure of angle 1 would equal 1/2 arc AB, or AB would equal 2 times the measure of measure of angle 1. Then we got into our floating angle, which is the one that's inside this circle but not on the center. And the way we find that measure is by adding the arc it intercepts plus the arc its vertical angle intercepts, and then dividing by 2. So it's 1/2 the intercepted arc plus its vertical angle's intercepted arc. Then came the angle formed by a tangent and a chord. So angle 1 here, and that's equal to 1/2 the arc it intercepts. 1/2 arc AB would give you angle 1, or angle 1 times 2 is going to give you arc AB. So angle's 1/2 the arc. Again, that vertex is on the circle, so it's a lot like the intercepted arc, or the inscribed angle, sorry. Then came the exterior angles, so all the angles that are outside the circle. So whether it's 2 secant segments like this first one, or a tangent and a secant, or 2 tangents, they're all that big minus little divided by 2. So if I was looking at that first one, I would do big arc minus little arc divided by 2 equals angle 1. Second one, big arc minus little arc divided by 2 equals angle 1. And the last one, big arc minus little arc divided by 2 equals 1. So for the first two, they have to give you 2 of the 3 measurements, but this last one is the one where you can get just 1. So let's say I gave you that this arc was 200. Because there's only 2 arcs in that circle, I could do 360 minus that to get 160 for the smaller arc, and then I could go from there. Okay, then came everything we talked about in this section, which was the segments. So this first example is the 2 chords. The 2 chords you would break into segments, and the product of those segments would be equal. So in this diagram, A times B would equal C times D. Then, so that's the 2 chords. Then you had 2 secant segments, and this is whole times external equals whole times external. And last but not least, tangent and secant segments, and this is tangent squared equals whole times external. Okay, you can use the remaining time to work on your assignment, which is on Canvas. Remember, it's due tomorrow morning, and then tomorrow we'll review and go over the warm-up, and then we'll do 10-7, which is the last section in the chapter. Have a great day, guys.